we consider the rational function y equals, well, you can read it, okay? We want to find the zeros of the numerator and denominator. It's the first step in graphing any rational function. We find the zeros of the numerator and denominator. We also want to find the y-intercept, which is very easy. We plug in x equals 0. In this case, we get 5. The y-intercept is at 0, 5. So I'm going to go ahead and put that on the graph. I hadn't done that before, but it's always risky writing a label before we do the graph, but okay. Now let's see how we got the other characteristics of this graph. The numerator zeros are easily found. It occurs when x plus 3 is 0, x minus 1 is 0, or x minus 5 is 0. That's at x equals negative 3, 1, and 5. The denominator is 0. Now the denominator is not in factored form, and there's a good reason for that. The denominator can't be factored over integers or even rational numbers, it turns out. So when is a denominator 0? Well, it's when the denominator is 0. We get an equation. Set the denominator equal to 0. We have an equation we can solve to find when it's 0. Now, having this equation, how can we solve it? We could solve it by factoring if possible, but it's not possible in this case. We could factor by completing, or we could solve the equation by completing the square, and that always works. Or we could factor using the quadratic formula, which also always works. Okay, well, the quadratic formula being the easiest choice, we go ahead and plug into the quadratic formula. Now the details are as they are. In class, I carelessly wrote this 0 as plus 7, but it's minus 7. I also indicated a 0, the denominator, at x equals 0.7. Well, let's see. What we do on the graph is we're going to summarize where the zeros are. That's at x equals 3, 1, or 5. And then we're going to indicate where the zeros of the denominator are. We expect that a 0 of the denominator will result in an asymptote, a vertical asymptote. That won't always be the case because sometimes a factor of the denominator will match a factor of the numerator, but it is usually the case. When the denominator gets close to 0 and the numerator doesn't, the closer the denominator gets to 0, the bigger the result. Positive or negative, but it's going to be big, which is going to drive the graph up or down. Now, I indicated the zeros of the denominator. They occur at x equals negative 4.3, and I mistakenly believed what I wrote here and said it was at x equals 0.7. This ran us into trouble later on when we were trying to construct the graph. So I need to change that right now. So I'm going to make that change off camera. And now the graph appears correct. And we have x equals negative 0.7. That'll be a suspected vertical asymptote. So once again, we've asked the question, where is the numerator 0? Where's the denominator 0? We've indicated the 0 of the numerators, which will be zeros of the function. There's no way this can be anything but 0 if the numerator is 0, no matter what we divide by. It might be undefined at one of those zeros, but of the numerator, but we'll deal with that later. Turns out that's not the case. The zeros of the denominator occur at negative 4.3 and negative 0.7. And again, for the reasons I indicated, we indicate that as a potential vertical asymptote.